Hey everyone. So for those of you who don't know me, my name's Alec, and I spend most of my time working on a GraphQL client called Houdini. At its core, Houdini solves a lot of the same problems as a lot of the GraphQL clients out there. But where we do something a little bit differently is we try to take a more holistic approach and provide a solution that sort of addresses routing, bundling your GraphQL client, and sort of how to wire it all up together. And that might seem a little bit weird at first, but it gives us some cool opportunities to solve a lot of problems for you that you don't otherwise have to think about. But before I get too deep into Houdini, I'd like to just take a few minutes to talk about something that's both equally exciting and unfortunate. So if you look at a lot of the talks that are given at today's GraphQL Conf, you'll see that a lot of the people sharing ideas come from really large companies like Netflix, Meta, Atlassian. And this is really cool. These are very large companies, and that sort of speaks to GraphQL's power to structure APIs. Otherwise, they wouldn't invest the resources to support it, and they move slowly. That speaks to the longevity of the technology. And then, frankly, just more people using GraphQL, the better, discovering useful patterns, and we all just sort of benefit from that. But these are very large companies, and they have problems that are very different from smaller companies who either are just starting their GraphQL journey, or maybe they're trying to figure out if GraphQL is the right fit for them. And so if you're not one of those companies, then you may feel a little bit disconnected because you see a lot of conversations around federated schemas and composite schemas. And frankly, if you're not one of those large companies, you probably don't need federation. And so like I said, that might lead you to feel a little bit disconnected, and maybe you don't feel like GraphQL is really the right fit for you. And no one would really blame you. If you go on social media, a lot of the conversation is sort of labeled GraphQL as maybe too complicated, or maybe there are better solutions out there like TRPC for your use case. At his keynote last year at GraphQL Conf, Theo Brown showed this diagram to sort of talk about this problem. And I think for a lot of the common solutions, this sort of hit the nail on the head. You have a solution like React and NextJS's server components. And because they're just using built-in React features, it feels relatively simple. Okay, there are some downsides to the server component model, but it feels very clean just using built-in React features. Kind of a step up from that, you've got TRPC. There is sort of a distinct server and client, but you can just import your server into your client and just start using it as if it wasn't a separate thing. And then on the far end of that spectrum, you have GraphQL. We also have that client and server divide, but it comes at a significant cost in the complexity. And so you may be asking yourself, why does this really matter to us, the community inside GraphQL? And I think what the important takeaway from this is that while we may all think that this is really great, this increase in complexity creates a very significant barrier to newcomers into GraphQL as they try to figure out how to sort of adopt this to the team. They see that there are sort of these other solutions. And so it's important for us to acknowledge that newcomers, they may not be as sold in and may not think that a lot of this is worth it. So here's another chart from Theo, and it sort of reframes the problem in a different way. And you guys can see that the common solutions for GraphQL have really fallen short when a team is maintaining a single app where the front end and back end are both written by TypeScript, and that lives in the same repository. And so, why is that? What about TRPC makes it such a more palatable solution for newcomers? And I think there are a few different reasons, but most of them stem from the fact that we sort of have all of the different clients that exist in the GraphQL, they were built to be backend agnostic. One of sort of the core principles of GraphQL, one of the tenets from which our entire ecosystem of tooling was created, is that we have this static schema that represents our backend. And that's really great, but what it does is it's created from that, the clients can sort of build really robust caching strategies and provide you all of the tooling that you need to sort of build these hyper-efficient UIs. But again, comes at a significant cost and complexity. You have to generate that pipeline. You have to wire up all these cogen pipelines. You have to make sure that that static representation of your schema never falls out of date from your API if you decide to update the API. And so if you do find yourself in a situation where your client could potentially reach into your server and use that logic directly, all of this hassle becomes less and less worth it. So In this talk, my hope is to sort of show you why I think Houdini is, the position to kind of fill that missing quadrant. Now, okay, that's a little tongue-in-cheek, but I do actually think that Houdini does have a little bit of something to offer for everyone in this graph. And so with that, I think we can sort of take a step into Houdini. Okay, so I'm not going to be able to go super deep into a lot of the details about how Houdini works. I'm going to try to give kind of a really rough introduction so that you can at least sort of follow the live coding examples. If you want to know more about Houdini, I gave a talk at GraphQL Conf 2 years ago where I sort of go into a lot of the details and like a behind-the-scenes look at how this all works. So I highly recommend, ooh, I should not touch that. I highly recommend, guess I should have guessed that given the problems. I highly recommend giving that talk a look if you wanted to sort of see more. Okay, so the best way to think about Houdini is sort of a mix between I guess I should just, all right, is a way to, an interaction between your GraphQL client, your client-side router and your GraphQL layers. See, here's where notes would have been helpful. And so let's just dive right into that. So like most application frameworks these days, Houdini uses a file system-based router. I know for a lot of people out there, file system-based routers have sort of fallen out of favor, but I do think for a problem like Houdini, they're sort of the perfect solution for what I'm trying to do here. If you want to talk more about file system-based routers and why you think they suck, I'd love to hear your input. I do have some ideas, but regardless, all of your routes are defined by a directory that lives underneath source routes, and all of your pages themselves are defined by a page file. The first thing that probably stands out is that page is prefixed with a plus. This is a convention that I borrowed from SvelteKit, and it has a number of benefits as your application grows, but the most important one is that it sort of pulls all of the Houdini-specific files separate from the files that you may have added as, that your team needs for their own needs. Okay, so just that one page, your application has a single route, lives at // and it renders the component that's defined in that component. Okay, cool. So if you want to add multiple routes, I didn't even touch it. If you want to add multiple routes to your page, you just define multiple page files, each in their directory. So here you can see that we have those 4 routes that are defined. And what's really nice about this is that you can quickly navigate to the exact component that you need for a given view. So when you find a bug, you know exactly where to at least start your search. And as you jump between Houdini projects, it's really easy to get a quick lay of the land by just opening that source routes directory and seeing how everything is organized. Okay, so with that out of the way, now we can talk about how to sort of fetch data into your application. So just like your views are defined in page.jsx or tsx files, your queries are defined in a GQL file that lives next to it. And so those 2 files are all that's necessary to load data into your app. And I know it's kind of crowded there, but hopefully you can see that in the GQL file, we've defined a query named all shows, where we get all the shows from our UI, or from our API, and then we render that in a component in that page file. This time, the view component accepts a prop, all shows, with the same name as the query, and we take all the shows from our API and we render a div with the show name. Okay, so the next thing to talk about is query variables. So query variables are encoded as brackets in your directories. Again, a convention I borrowed from SvelteKit. So here you can see that with that show /ID in brackets, we match anything with show / and then an ID. And because only that one page is defined, we don't even match show /ID / info. There are ways to do splats and have groupings of your URLs, but I didn't want to I'm already sort of running out of time, so I didn't include them here. So if your query has a variable that with the same name as one of the URL route parameters, then Houdini will take the string out of the URL, marshal it into the appropriate scalar, pass that on to your query. And so those 2 files on the right are really everything that you need to power this view by your URL. Navigating to show /1 shows you the appropriate show's name. And okay, so like I said, that was really, let me go back here. This is really the crux of what I'd like to sort of convey about the client-side router for this talk. There's a lot more. Please go check out the other talk if you want to know more. But I think the sort of other part of this is our backend integration. And here's where you can really see how Houdini fills that quadrant from before. So again, my thesis for how to do that is to sort of reduce the number of hoops between the schema that you have for your business logic and the UI. And so if we try to remove as much of the boilerplate and just meaningless stuff as possible, the simplest thing that we could get is a single schema that lives under source API. Inside of that, you just have to export a schema that, in this example, is generated with the create schema from Yoga, but that could have been done with like a GraphFast situation. Hopefully, there's a Gratz implementation that we can figure out. But the idea here is that you can focus on encoding your business logic as an executable schema, and everything else is sort of taken care of for you. Houdini takes this schema, wraps up in a GraphQL Yoga server, deploys that on an API endpoint that you don't really have to worry about, and everything is sort of tucked away behind this internal API. The other thing I'd like to call out is that this file is the only thing that you need for the codegen pipeline. The compiler just imports the schema that you've executed here, loads it into what it needs to do, and so there's no worry anymore that, oh, my API updated, but you haven't pulled down the latest description to run the rest of your codegen pipeline. Maybe you did and you forgot to restart your server. All of that is sort of bundled up nicely into Veet's file watching for us, so changes here are instantly reflected on your UI. If you do need to do something special, you always can define a plus server file, which just basically lets you wrap up whatever server logic that you need. As we'll see in a few minutes, the value that's exported from this file is just a really lightweight wrapper over Yoga. And so that basically gives you all of the envelop plugins. Right now, I've just sort of focused on using Yoga as the server, but my hope is that ultimately this directory sort of becomes like an integration point for any other kind of server-side tooling that you may want to add to your app. I have some more ideas for ways to use this, but we'll get to that at the end of the talk. Okay, so it's time for some live coding. Hopefully okay, cool. Looks like that is all working. That looks big enough too. Okay, so before we get too far, let me just take a second to sort of orient what we're doing here. So for this project, we are going to be looking at a Houdini implementation of Trellix. For those who don't know, Trellix is a Trello clone written in Remix that Ryan Florence popularized. And the idea is to sort of have an application that has some real-world scenarios that a to-do list is not great at illustrating. So to kick off the Houdini app, all you need to do is do pnpm dev. You'll see our pipeline is run, and Veet has started a server for us. So now if we get in there, you can see that we can create a board. So let me make a board called to do. I can go into that board. I can make some columns. So backlog, in progress, completed. And then I can add cards to that, to each column, and then I can move that card between the columns. So pretty much everything that you would expect to happen exists. So right now this delete doesn't work. We'll go and implement that together. But before we get there, I kind of want to start off simply, and let's just orient you to the project, and then we'll go add some things. So the first thing is, let's just dive into that server file. So this is a server wrapper that comes from Houdini, but as you can see, we just have Yoga plugins. And so this is, again, just a really lightweight wrapper over Yoga that sort of teaches Yoga how to think about Houdini's conventions. For this situation, the server or the app is a wrapper over a SQLite database, and so that way as the server restarts, we have the data persists. Inside of that schema file, we grab create schema from Yoga, and if you've done any kind of backend work in Typescript, this should look pretty familiar to you. We've got our type defs at the top that define everything, and then our resolvers down below. So what I'd like to do now, maybe let's show you the routes. Okay, so most of the work that we'll be doing is in this board ID directory. So for our use case, we really only have that one page. So here's the query that we're looking at. You see that it takes in one argument ID. It's required. It pulls the ID out of the router, and it renders the information that we need for the board. So the name, the colors, columns. I don't necessarily need to jump in to show you how the column component, because it's mostly just a duplicate of the card. So here's how the card component works. You can see that we have a use fragment hook, which is very similar to relays. And a lot has been said on like the virtues of co-located fragments. So I don't need to repeat that. But basically, the idea is that we can have all the data that we need that sort of lives in this for the card. So what I want to do now as sort of our first exercise is to add a little date stamp that'll show when this card was added to the server. So let me open up the snippets so you guys don't have to watch me debug typos. And so what I'm going to do now, the first thing to sort of recognize is that our card doesn't have a date created column. We don't even really have a date time scalar defined in the schema. So let me just go ahead and add these things. So I'm going to import the date time. I'm going to import date time from GraphQL scalars. We're going to have to add the scalar definition. The field needs to be added to the card. And I need to just add a few more resolvers. So again, if you've done any kind of sort of node work on the back end of a GraphQL API, this should all look pretty familiar. And so I'm going to save. You'll see that Vite detected that our schema reloaded, so it reran the codegen pipeline. No documents changed because nothing's using this value yet. So let's go ahead and change that. I'm going to add that date created, and then we'll save that. So I'm saving, automatically running the codegen pipeline. Red squiggly lines went away, which means the type generation is all good. So you can see that we have that board info card component type that we got from Houdini. So I'm going to grab format distance from the date functions and then come down here where the text is, and it's down below. There, and paste. Okay, so the first thing that I want to call out is that you can see that this date created field is a JavaScript date. So Houdini has full support for GraphQL scalars, so it knows that when it's pulling values out of the runtime, it needs to marshal that into a JavaScript date. And so we can pass that on to format distance, and you can see that it's there. So hopefully you can sort of get an idea for the higher mental model. We can go to our schema, we make the changes that we need, and then we can immediately jump to our UI and use those values. And so I want to kind of take it up a notch. I'm only going to show you this one more time. I think you guys can sort of see how this is going to go. And so what I'd like to do next is make this trash can actually work. And so that looks like more of the same. So the first thing we have to do is add this delete card field to our mutations, and then we need to define the output type. And then the last thing we have to do is actually grab this resolver. So let me grab it. It ends there. Come down to the resolvers. We'll paste. Okay, so no errors. The code generation ran, but again, we're not using the mutation. So let me go ahead and define that callback. So here I'm using the use mutation hook from Houdini. If you've used a GraphQL client, this should look pretty familiar. We just wrap our document in a GraphQL function, and what we get back is a callback that we can call. The first thing to sort of call out here is that I didn't need to provide any kind of template parameters or anything like that. Houdini generates types for the use mutation hook to match the documents that you pass. And so it knows because you've passed that document, there's really only one callback. And so the idea here is to sort of, again, hide as much as I can and do whatever I can to sort of streamline that developer experience. So with that defined, the only thing that's really left now is to come down to that trash can and actually use the callback. This, again, should look pretty familiar. We pass in some variables. We pass in an optimistic response. This is more just par for the course for any kind of GraphQL client out there. So let's see this work. So because there's an optimistic response, this can go kind of quick. So what I'm going to do here is I'm going to clear that. And then I'm going to delete the card will vanish. And then once you see it vanish, sort of shift your eyes over to the network pane on the right and see that the request hasn't resolved. So delete, card's gone, but we still have a pending request. So that's all cool. And so I think with those two examples, you can sort of see the mental model here. You need something, you need to work on something, you can just go to your schema. You really don't have to think about your world outside of an executable schema and your UI that uses it. It's also worth mentioning that because this is tucked away behind an internal API, the security model is pretty easy to wrap your head around. There's no opportunity that you leaked information. I mean, you can see in this example, we're accessing a SQLite database. And so rather than just spending the rest of my time just like showing you this example over and over, I want to sort of take the rest of my time to talk about maybe some of the tricks that I'm pulling behind the scenes. And if you do decide to pull this project down, I want you to be able to kind of appreciate what's going on here. So the first thing to talk about is a sort of an issue with optimistic responses. If you think about the way like an optimistic create works, you have this value that exists in your cache before the server's actually done anything. So to sort of see a problem with that, let's go to where the create card is used. And I'm just going to start providing an optimistic response. Okay, so again, if you've used any other client, you know that the optimistic response has something that looks a lot like, oh, is it going to do it? Did it do it? Yeah, that was hit or miss when I was trying to do this. Okay, so this is all, I need to add date created. Date created, and then we're going to come down here, and date created is new date. I don't need that, but I appreciate the attempt. Okay, so most of those fields are things that what the hell? Most of those fields are things that we know at the time of creation. We know the text. We know we're just going to say that it was created now, no problem. But the issue arises with what ID do we actually provide for the optimistic create. So maybe the naive thing is to do what, I don't know why it decided to have it be all of that complexity. You could just do a math.random to string. And so like this, oh, throttling is on. So this will work. You know, we can come down here and we can say, hope this goes better. And, oh, I need throttling on now. So add a card. And again, this will work. Card was created, pending request, it's added. But there's something that happens that can be pretty problematic with optimistic creates, and that's if I decide to send another mutation relative to the card that I just created. So let me make a second card. And what I'm going to do now is I'm going to create the card, and then before that create resolves, I'm going to send the delete mutation. So create, delete. So you see we have two pending requests. The first one resolved, and then we got an error on that second request. So if we dive into what actually is happening, it should probably be what you expect. The server says it didn't know what to do with that random string that was generated. And so this creates kind of an issue, because for a lot of clients out there, optimistic creates are something that you can't really support. Orchestrating this can be pretty nasty in the other clients. But Houdini has a little trick up its sleeve, and that comes in the form of the optimistic key directive. So the idea with the optimistic key directive is that you tag a payload in the mutation response with optimistic key. And this acts as an instruction to Houdini that when it's handling an optimistic update, it can generate a random value and then track that value internally. If that value is then used as the input for another mutation, Houdini recognizes that there's a dependency between those two mutations, so it can handle the orchestration for you. That can be a little bit hard to track in the demo that I'm about to show you. So just to quickly visualize this, I put one of these diagrams together. I know these diagrams suck. I'm sorry. I spent a lot of time trying to figure out an alternative to these diagrams, but this is where we are. Okay, so the first thing that happens is that the card's created. This makes two things happen simultaneously. The first is that we submit an optimistic payload to the client that has this magic ID. Also, we submit the create card mutation over to the API. Before that create card mutation resolves, the user goes and deletes the card, again with that magic ID as the optimistic payload, and Houdini cleans up the UI because it just keeps seeing that consistent ID. Crucially, what does not happen is we do not send the delete card mutation out to the server. Eventually, the create card mutation resolves, and Houdini goes, oh, okay, I now have a value for that magic value. It's 7, and so then it can send the mutation out to the server, and that's why the server won't fail. I didn't touch anything. That was not me. Okay, so let's just see that in action. This goes pretty quickly. So like I said, all that we really need to do for our situation is tag this with optimistic key. I hope I typed that right. And we can delete the ID that we provided in the optimistic payload because, again, Houdini will generate that for us. Turn off throttling so these assets load. And then turn throttling back on. Okay, so again, what I'm going to do here is I'm going to make a third card. I'm going to create delete. Once you see the card go away, shift your eyes to the bottom of the network tab on the right, and you'll see that there's one pending network request. Then that will resolve, and then the second request goes out. So create delete, one pending network request, and then the second one goes off, and the API had no problem deleting the card with ID 4. Thank you. Yeah, that went surprisingly well. Okay, so it helps having the snippets. It's almost cheating. Okay, so the last thing that I kind of want to talk about, that everything that you've seen so far is available on NPM. This is just how Houdini works and everything. There is nothing sort of unpublished here. But what my last point that I'd like to kind of make with this talk is about the future of Houdini and sort of how I see things growing. And that's something that I describe as full stack modularity. And what I mean by that is basically Houdini already has a pretty extensive plugin system to give you all a plugin into the codegen as well as into the runtime. What I don't have is a plugin system for that server wrapper. And if you do have something like that, coupled with our support for fragments, enables a pretty interesting story where people could ship sort of entire feature verticals onto NPM. A server-side plugin could augment the executable schema that you had wrapped up in the server. And so a company like Auth0 or Clerk could ship an entire user management system that you pull down into your app and you plug right in. You could imagine that this could include all the mutations for registering a server, as well as a collection of sort of headless fragments that let you do everything that you need to take the Auth0 user and wrap it up into your own custom components and have it look the way that you want. And my final note, I'm over time, so I have a lot more to say on that, but rather than going over even worse, just some final remarks. I think the right way to sort of end this off is to come back to this chart. So in his keynote, Theo also showed a second chart, which is basically the same thing, but this time it's labeled capability instead of complexity. And I think this is why we're all here. We all agree that GraphQL is almost certainly the most feature-packed way to build a UI. There's so many benefits, an entire ecosystem of tooling. You can really do some really amazing things with the technology. But historically, this has come at a significant cost of complexity. As some of the most advanced users in our ecosystem, it was really easy to just assume that it wasn't that big of a deal. But for newcomers, it's pretty clear that GraphQL has sort of struggled to find its position. Hopefully now you can see that we don't have to accept the complexity in order to take advantage of the capability. And if you're just starting your GraphQL journey, I hope that you consider Houdini as sort of your shepherd through GraphQL, because we'll try our hardest to keep that barrier as low as possible for you. All right. Thanks, everyone. I doubt we have time for questions. Okay.
Can every ID be an optimistic?
Yeah, and for situations where, because Houdini has support for multiple keys per thing, so the only caveat there is you just need to make sure that every field that is a key for your object gets the optimistic key decorator.
So can it be like automatic in a certain sense? Like
it could be, but because it does have implications, like I think Dan Abramov has kind of an important perspective on this, where like optimistic updates they're lying to your user. it's really easy to assume that you have an optimistic update, you close your browser, and that second mutation was never sent. And so rather than having it be something that just always happens, I do kind of like them as an opt-in because I want the user to very explicitly say, like, I'm okay with that uncertainty sort of being baked into the application. There isn't a config that says do it for everything, but it's definitely doable. There's nothing that is conceptually stopping. Yeah.
Is that not something that could be handled on the server side, like rather than waiting for the request to get back? Like it still sends both the requests and then the server just kind of holds it until the first one.
Yeah, I don't know if there's a way. I think I saw a spec proposal, but I don't think there's a way to send two mutations and have the input for one be tied to the output of another, which is really, you need something that sits at the runtime to look at the return values. It would be really interesting to have something that's, does that, but I don't think it's supported right now in the language.